Hello everyone, welcome to DigiClub Solutions. In this video, we are going to write a C++ program to swap two numbers in four different ways. So the very first approach, using a temporary variable, and this is the most straightforward and commonly taught method. Let us see how it works. Okay, so this is a basic template for a C++ program. What we will do is, let us have two variables. So we have A with the value of 5, we have B with a value of some 10. Okay, now let us use a third variable, so using which can store the value of A. So let us have a third variable which will be initialized to 0 by default. Okay, now let us store the value of A in temporary variable. So let us store temp is equals to A, and in the next line, now we have stored our A value in temp, right? Now we have to change the value of B to A. So what we can do is, let us assign A is equals to B. That means we have swapped one value. Now the value of B is getting stored in A. That means now A is storing 10. Okay, so we have swapped one value. Then what about A value? As we remember, the value of A, which is 5, is getting stored in temporary variable, that is temp. Okay, now simply what we can do is, B is equals to, we can just assign temp, that is the value of A. Okay, so this way we can use a third variable and we can swap two values, two numbers. Now if you try to print the values of A and B, and before even swapping, let us try to print our A and B values. Okay, and now if you run this program, you can see the output as 5, 10 before swapping, and after swapping it is 10 and 5, which is our main goal. So simply, what is this approach? You can store the value of A in a third variable, a temp variable, and later you can have the value of B in A. That means we have reassigned the value of A to B, and finally in B we are storing the value of A, which is stored in temp. That means temporary variable. So this is the most straightforward approach. Now let us see the second approach, that is using addition and subtraction. So what is the benefit of using this approach? This method avoids the use of an extra variable. That means in the previous approach we have used a third variable temp, right? So in this approach we can avoid the temporary variable. So you can think this as an optimization to our previous solution. So what we can do is, simply let us see a kind of logic. Okay, so we have two variables n1 and n2. So we have two numbers n1 and n2, and we have a sum, so where we'll be storing n1 plus n2. Okay, so our sum is storing the addition of n1 and n2. Now if you want to get n1, what you can do is, you can subtract the value of n2 from the sum. Okay, and if you want to get the value of n2, what you can do is, you can subtract the value of n1 from the sum. That means the sum consists the addition of both number 1 and number 2. So if you want to get the number 1, you have to subtract the number 2 from the sum. Okay, in the same way, if you want to get the other variable, you have to subtract the remaining value from the sum. So that is how we can get the values. Okay, we are going to use this principle. So what we will do is, first let us try to store the sum. Okay, so A is equals to A plus B. That means here our A is storing sum, which is equals to 15. Okay, and in the next line, B, so I want the value of B, right? So what I can do, I can subtract. See, we have the sum, and you can subtract the value of B so that you can get the value of A. Okay, so I will be swapping the values. That means we have to store the value of A in B. So B is equals to what is my sum right now? A. So I'll subtract the value of B so that I can get A. Okay, so we got the value of A by subtracting it from the sum. That means now what is the value here getting stored in B? So A is the sum, which is 15, and B value is 10. So here we have swapped the values. That means now B contains 5, which implies that it's almost A value. So we have swapped one value. And in the next step, let us reassign the value of A. Okay. Now what we are trying to get, so we have swapped the value of A to B. Now what about B? So B has to get stored in A, right? So who is our sum? A is our sum. Okay. And at this moment, what is the value of B? So B is storing 5. So if you subtract B from the sum, you'll get the value of A. Okay. So just subtract this, and you can see that the value is getting stored is 10. So the total sum is 15 and the value of B is 5. So we got 10. So we are storing 10, which is the initial B value, to A over here. Okay. So here the value is 10, which is B. So we have swapped our two values using addition and subtraction. Now if you run this program again, you can see the output as, oh sorry, we are not using this, still we have declared it. Now if you run this, you can see that value is 510 before swapping, and after swapping it got changed to 10 and 5. So this is the second approach. Simple logic. You just need to find the sum, and you have to subtract one value from the sum to get the other value. So this logic will be used in addition and subtraction. I hope it is clear to everyone. Now let us discuss another approach using Zord bitwise operation. Okay, so this method uses Zord bitwise operation to swap the values without a temporary variable. This is even more optimized because it works at bit level. So that is what we have to remember. Now let us see in code. I'll delete all this. So Zord has an interesting principles. Okay, if you have a number, and if you, this is a XOR operation. If you XOR a number with 0, you will get the number itself. Okay. And the second most important principle is, if you XOR the number with itself, the result will be 0. So this is a main two principles which helps in swapping two numbers. So XOR operation is very much interesting. So these two main principles of XOR operation will help you to swap the two numbers without even the need of a third variable. Okay, so what are these two principles? If you XOR a number with 0, you'll just get that number itself, or if you XOR a number with itself, the result will be 0. Okay, now what I can do is, see, first I'll store the XOR of A and B in my E. Okay, so this is XOR of A and B, which is getting stored in A. Okay, in the next step, I'll try to assign the value of B as A XOR B. Okay, so what is happening over here? Very simple. This line implies that B is equals to, what is the value of A? We have stored the XOR of A and B in the previous step. So here the value of A is A XOR B. Okay, next. Again we are doing a XOR with B. So what happens? Again a XOR with B. So B XOR B. So a number XOR with itself will give rise to 0. So in the next step it will become A XOR 0. And what do you, what will get the output as when you XOR a number with 0? The number itself. Okay, so in the next step we'll get A. So in this line what we understood is we have swapped the value of A with B. Okay, now let us go to next line. In the same way, A is equals to, again the same operation, that is A XOR B. Okay, so what is the value of A over here, let us see, let us try it on this. So what is the value of A? This is A Zord B. And what is the value of B over here? See, the B got initialized to A in the previous step. So here the B value is A, which implies that A XOR A will become 0. That means B XOR 0 will be our next step. And in the next line, when you XOR a number with 0, the result will be that number itself. So here we'll get B as an output. So by having these three steps, we can swap two numbers without the need of a third variable. Okay, so hence we have swapped two numbers. And if you run this program, you can see the output as 5 and 10 before swap and 10 and 5 after swap. It is as simple as that using XOR operation. And the two main principles used is number XOR with 0 will give rise to number itself, and if you XOR a number with itself will give rise to 0. Using this approach, we can swap two numbers. Then what about the next approach, which is the most optimized approach using the inbuilt swap function? Okay, so this is part of standard library and is optimized for swapping. Okay, see, anything which is given by the developers, the C++ developers, okay, or the creators will be more optimized. Okay, so what we can do is, instead of doing all this, we have a function called as swap, and you can just give the two values of A and B. It will immediately swap the two values. And one more thing, this belongs to a third party library. That means it is stored in a particular header file. In order to use it, you have to include that header file in your program. What you can do is, it belongs to utility header file. Okay, so in order to use swap function, you have to include this header in your program. So swap of A comma B will just swap your numbers. Let us change the value of A so that we can see the difference. Okay, and now if you run this program, you can see that before swap the value of A and B are 6 and 10, and after swap it is 10 and 6. So this is the most optimized way of swapping two values or two numbers. Okay, I hope you like this video, so please do subscribe to our channel, and thanks for watching.